So we will continue with the printing of the sensors. First, I will give a short introduction of Fraunhofer Institute, and then I will come to the details about the printed sensors, printed piezoelectric sensors, which we use for impact detection, and printed thermocouples for temperature measurements. Yeah. So Fraunhofer Society has more than 32,000 employees, and we are located nearly overall in Germany, and have a total research contract volume of more than 3 billion euros. Especially our institute, Fraunhofer Institute for Manufacturing and Advanced Materials, we have 7 locations. Main location is in Bremen, where Andreas and I working. And in total, we have more than 700 employees and total budget of more than 70 million euros. Here you see an overview about our core competencies. We have 7 in total. Yeah, so we are dealing with metallic materials, polymer materials, surface technology and component manufacturing, and also automation, robotics, adhesive bonding, and energy storage. And our business units are in 5 sectors. So main sector which is important for this Morpho project is aviation for sure. But yeah, we also work for in the field of mobility, energy, maritime technologies, and medical engineering and life sciences. So coming to the printed sensors, printed piezoelectric sensors are used for the impact detection of composite parts, and the aim is to ensure the aircraft safety and durability, and I will show how we apply the sensors on the composite parts, and also thermocouples for monitoring of the temperature changes in the aircraft components. Here you see on the picture test parts of carbon fiber reinforced plastic parts. On the top, you don't see so much because thermocouples are embedded in the lacquer system of the carbon parts. And on the bottom, you see printed piezoelectric sensors, 5 in total. We normally print 3 to 5. In this example, we print 5 to get yeah, statistic information about the sensors and about the signals. But for sure, we only need 1 sensor at 1 location to get a signal. So here you see the screen printing process, which we use to apply the piezoelectric sensors. We have a mesh, and a paste is transported via a squeegee. And yeah, when you have a contact to the substrate, to the where we would like to print the sensors, the sensors are printed, and on the areas where we do not want to apply material, the mesh is covered with an emulsion. This is a non-printing area. To see on the top is the fluting process, where the paste is yeah, deposited on the screen, and then the printing process, the squeegee presses down the mesh, and then the printed structure will be deposited on the top of the part. So here you see the machine, the screen printing machine with the screen and with the mesh, and you also see the paste, and on the bottom you see the part, the carbon fiber reinforced plastic part, which you have also seen before in the presentation of Vladislav and Andreas. And yeah, you also see some printed structures on the part. The screen printed piezo sensors consists of a 3-layer structure. We have a bottom electrode and a top electrode, and in between is a piezoelectric layer. The electrodes are, for the electrodes, silver conductive pastes are used because we need good electrical conductivity. And for the piezoelectric layer, use piezoelectric lacquer passed from Alga, which is in between the electrodes. So, and when we have a closer look on the printed piezoelectric sensors, you will see here the thickness of the structure. It is 135 microns for the layer thickness. This is to get an feeling for the structure and for itself. So here you see the panels with the printed piezoelectric structures. After printing, they have no function because they are unpolarized. So we have in the piezoelectric material is not orientated, and so when you get a signal or something, you cannot measure anything. And for orientate the dipoles in the piezoelectric material, we need an electromagnetic field. So we apply a voltage and a temperature for half an hour, so 300 volts and 100 degrees. It will put in an oven, which you can see on the right picture, and this is connected with the cables, each sensor to apply the voltage. And in the process, so during the sintering in the oven, the dipoles in the piezoelectric paste are orientated. And yeah, after orientation, we get a signal when we have an impact on the sensors, which you can see on the right picture. So you can tap on the sensor, and then you get a signal. So we would like to use these sensors for impact detection, and you can localize an impact when you have 3 different sensors on different positions. And then you can calculate the time of the signal from each sensor, and calculate the time shift. You can localize the area where the impact was on the panel. So also we apply thermocouples. For thermocouples, we use an aerosol printing process, which is shown on the right side. This is a very fine structure. We have a nozzle where aerosol is generated, and using a pneumatic nebulizer, and then it is focused and transported to a printhead, and then focused again, and we have an aerosol stream. This is very, very small, and then we can apply the material on the substrate. And for the thermocouples, we use copper and copper nickel, because this is a common thermocouple pair, where we get temperature information. And so some more details to the machine. You can see here the printing speed and the area. I do not want to go in all the details. Great advantage is that we have a 5-axis system, so we can rotate also the samples in different positions. Oh, sorry. You can see it again, and you see on the right side, you see the nozzle where the structures are printed on the FOD panel, and you also see a small shutter. It is shown here, and where you can interrupt the aerosol beam during the printing process. So on the right picture, you see the copper and the copper nickel structure, which are printed on the part, and on the junction, this is the area where you can measure the temperature. You see on the bottom, you see several printed thermocouples. Also to get different signals and to see how get some information about the statistic and the reproducibility of the process. After printing, we need a sintering process. We have very small structures, and then we can use photonic sintering. Photonic sintering is a surface plasmon resonance effect, so it depends on the size and shape of the nanoparticles. And which you can see here that we have a xenon lamp, which is on the right side, and when we have a flash, energy goes into the particles, and then the ink additives and material which are in the ink, which are not good for the electrical conductivity, evaporates, goes out, and then we will get a metallic structure. This process is very fast because we only need a very fast flash to get the sintering process. And here you see the fully sensorized FOD panels, which you have also seen before in the presentation of Vladislav. We have 5 positions for the piezoelectric sensors, one in the middle and also in the edges. I described before, we need 3 of the sensors to detect an impact. So when we have an impact, for example here, then we can calculate the signal time to here, and to here. So we need only one of the sensors so it is better to have more to get more information. And it is hard to see the temperature sensors because they are very, very small in contrast to the piezoelectric sensors. And you also see here the fiber optical sensors coming out here. Andreas showed this in the presentation before. Having these panels, we do in the project, in the Morpho project, a lot of tests to get information about the sensors, and also to measure the part when we get some stresses on it. Okay, so we have seen that we can print piezoelectric sensors and temperature sensors on the parts. The structure will not influenced and the properties because the sensors are relatively thin and they are located on the surface and they can be covered to protect them, and they will be used to get structural deformation, measure damage or fatigue in aircraft parts. And also monitoring of the temperature changes is possible. And great advantage of the temperature sensors that they can also integrate it in places where you can not go so easy, because we have the possibility to print these fine structures with the nozzle also on places which are hard to reach. This is not important for this panel, but for other structures or for other components. It is more important. So yeah, you see on the left picture again the panel with the piezoelectric, not with the temperature printing process, the aerosol process for the sensors. And yeah, so this is a short overview about the printed sensors. Thank you for listening. And yeah, if you have questions, feel free to ask afterwards. Thank you.